here we go. This is what? This is it for homework, yeah. And I think I changed it. Can anyone tell me, when did I make this due? It was supposed to be due at 3 today, because I did do tomorrow. Okay, that's what I thought.
The one that we're doing on Wednesday is due at 3.
Yes, okay. So if you don't finish this right now, then it's homework. But you're gonna submit this by 8:15 tomorrow morning. All right, here we go. Okay, my turn. Number 1, I need you to tell me, first of all, are you dealing with angles and arcs or segments?
Angles and arcs.
Angles and arcs, okay? So if you think back to your formulas, you're going to go, okay, angles and arcs formula, first of all. Second, tell me where your 2 lines meet up. Inside or outside the circle? Outside. When they meet up outside, are you adding or subtracting? Subtracting. Okay, so here's your refresher. The angle, I'm not going to call it 1. The angle always equals half of the bigger arc minus the smaller arc, right? That's the formula we're using right now. Angle equals half of arc minus arc. Arcs stay together, angles are by themselves, okay? What goes here? 38. 38 equals half of, what is your bigger arc? X. The one that's farther away will always be the bigger one, minus the one that's closer to, which is your 78, okay? Now, if you wanted to, you could distribute right here, but you need to be careful if you do it that way. What is my better way? Times 2. So if I multiply by 2, then I got to do it on both sides. So that's 76 equals X minus 78. Add that 78. I don't have an answer key in front of me. What is that? 154. So you get 154 degrees for the measure of that arc. It's okay. It's just a $100 calculator, no big deal. Oh, it made a pretty graph though, so that's fun. Okay. Number 2. Angles and arcs or segments? Angles and arcs. When there's degrees, it's angles and arcs, right? So this one is angles and arcs. Are they meeting inside or outside? Inside. So what are we doing when they meet inside? Adding. Okay. So this is going to be the angle equals half of arc plus arc. It doesn't matter which one's bigger or smaller because we're adding. Addition is commutative. So it's going to look like that. What is my angle? X, okay? We don't know the arcs for Y. These would be the arcs for Y. We could find them, but we don't know them right now, so we're going to start with X, okay? The angle equals half of what? 50 plus 78, right? This is the intercepted arc for X, and this is a vertical angle to that, so the intercepted arc over here is 78. So you just plug that into your calculator. Half of 50 plus 78 is 64. How do you find Y?
Wait, is like X supplementary to the one this like the angle across from it? Or no, it's like supplementary to the
Across from it like this. Is that what you mean?
So
Those are vertical, supplementary to Y, right? So this forms a straight line, right? Now you could find Y right now by subtracting from 360 and finding these. That's so much more work. Just, this is a straight line, okay? Straight lines are always 180. So you're just saying 64 plus Y equals 180. So take away the 64 and Y is that 116, I believe? Yeah. Okay. Questions on that? Okay. Look at number 3. Are you dealing with angles and arcs or segments? Segments. So new formulas, right? The segment formulas were different. When the point meets inside, remember this is the one that we said A times B equals C times D. But the idea you have to remember with these is you want to go from the point of intersection to the circle twice, right? From the point of intersection to the circle, and then from that point of intersection to the other side of the circle, okay? So what is my A times B equals C times D gonna look like here?
14x plus 12 times D.
Right, from the point to the circle is 14. From the point to the other side of the circle is x, so 14 times x equals, and then from the point to the circle is 12. From the point to the other side of the circle is 18. So 14x equals 12 times 18, which is 216. And then just divide by 14. Okay, those should be the easy ones. There's not a lot of steps. We would say x is approximately nearest tenth, it says, so 15.4. Okay. Number 4, angles and arcs or segments. Segments, and it's segments that meet outside the circle, okay? So this is the one, I forget what letters I did, but if it's like x times x plus y equals w times w plus z or something, whatever the letters were. You go from the point to the circle and then from the point to the other side of the circle still. Same thing as the step before it, the question before it, but it looks very different when you lay it out, okay? So from the point to the circle is 17. What's the distance from the point to the other side of the circle?
X.
No.
This is the wrong
Why?
formula.
Right. Well, I'm just showing you, this is like the general formula, right? What's the difference with this? How do I get to this point of the circle twice?
17
You square it, right? So this is the one where if it was tangent, you do t squared with it. But it's the same idea, from the point to the circle, from the point to the circle. So if there's only one distance to the circle, then you have to square that distance, okay? Okay, so you're gonna say 17 squared equals, and then you're gonna take that concept and drop it in. What is this, in our case here, our x gonna be? Not this x. This x is 9. You're going from the point to the circle is a length of 9. And then from the point to the other side of the circle is what?
X.
Not x. Has to be from this point. What is the distance? 9 plus x, right. This length here is 9 plus x. Okay? So if we square 17, you get 289 equals, I feel like most people distribute this one, so we're just going to distribute 81 plus 9x. You're going to take away the 81. So 208 equals 9x, and then just divide by 9. And you get 23.1. Okay. Okay, number 5 is also very similar, but instead of having a tangent, now they're both this setup that we started with initially, right? So x times x plus y, and then w times w plus z, however you want to think about that. So let's start with this one, okay? If I go from the point to the circle, it is a length of 5. What is the distance from that point to the other side of the circle? 5 plus 13, or you could just call it 18, right? You're welcome to do that if you want. The other side, from the point, what's the distance to the closer side of the circle? 6. What's the distance to the other side of the circle?
X.
Not x.
6 plus
6 plus x, right? That whole segment. So it's going to look like this, okay? Now simplify. There is no need to distribute right here, right? It would be kind of silly to distribute. You're just creating more work. Plug it into your calculator. 5 times 5 plus 15 or 5 times 18 is 90. Okay, so that side equals 90. This side, go ahead and distribute 36 plus 6x. And then we're going to take away the 36 is 54. And then we're going to divide by 6. How's your mental math? Good job. My son's doing multiplication tables right now. I love it.
Does he feel better?
Flashcard. No, that one is not feeling better. I went and saw him during my prep period, and
Do you live really close?
he has a sore throat and a cough. Yeah, I live like 6 minutes away. And a fever. So he just kind of a hot mess. Okay, this one did not transfer over very well. This should be a squared and a squared. So maybe just move those 2's up. This one tells you it's a circle, and they want the center of the circle and the radius. What is, I'm just going to put them down here. What's the center of this circle? 11, -4. Remember, it's always opposite of what it looks like. So a positive 11, a -4. And then what's your radius? It would be 12. This is your radius squared. So if you square root that, your radius is 12. Okay. Questions on that? Okay, so then this says, write the standard equation of a circle with a center of 4, 6 that passes through -1, 5. Tell me what variable we can attach to the 4. That's your H. What's your 6? That's your K. What's your -1? And what is your 5? Y. Okay, so if you take that with just the general setup, x minus h squared plus y minus k squared equals r squared, you should have numbers by the time you're done right here, and right here. Okay, the x and y in your final answer should stay x and y. So this is the one that I say, write your final answer right off the bat. Put a big box around it, but then solve for the missing piece, okay? So it would be, my final answer, x what? -4 minus your h value squared plus y minus 6 squared equals, and we don't know the radius squared yet, but this is our answer. Okay, the way we find our r squared is we plug in all of this, and we have all of that. We have hk, put your phone away. We have xy, right? So we're gonna plug those in. So it's gonna be x, which is -1, minus h, which is 4 squared, and then y, which is 5, minus k, which is 6 squared, equals our r squared. If I were you, I would plug that into your calculator exactly how you see it. It inevitably goes wrong when people do mental math and try to square a negative and keep it negative. Your calculator won't do that. Your calculator will make it positive. So if I were you, plug it in how you see it, okay? I'm not going to because I'm just going to do it in my head real fast. But this is a -5 squared. What is -5 squared? Positive or negative? Positive. Always positive. 25 plus, this is -1 squared. Always positive. So your r squared value is 26. That number goes right there. And that's your answer. Okay, like I said, plug this into your calculator exactly how you see it. You should get a 26.
I thought that the center subtracted the thing that it passes through, like 4 minus.
No, it's x minus h and y minus k, and hk is always your center. So that's got to go here. Okay. All right, number 8. Write the standard equation of this circle. What do you need to write a standard equation?
You need a center and a radius.
You need the radius and you need the center. What is the center of this circle? Is it 5? I can't even tell where that is. 1, 2, 3, 4, 5. Yeah. So -5. -5 is your center. What's your radius? 4. You can find that going any direction. 1, 2, 3, 4, right? So when it says write the standard equation, you're writing it just like this one. It's going to be x minus, this is h and k, so x minus a negative 5 is actually x plus 5 squared. And then y minus a negative 4 is y minus a negative 5 is y plus 5 squared. What goes at the end?
The radius squared.
Radius squared. So 4 squared, which is 16. Okay? Any questions on that? Yes. Okay, the locus. 2 of them here. Notice you have in a plane and in space. What's the difference?
Two-dimensional.
This one's going to be 2-dimensional. This one's going to be 3-dimensional, okay? So in a plane, the set of all points 4 centimeters from a segment, what do you get? A track, right? If you go 4 centimeters above and you go 4 centimeters below, and then you wrap around the end, okay, this is 4 centimeters in every direction. Yes, ma'am.
For these ones, do we have to like move it to like the where it says to put the answer, or can we just leave it like?
No, I'll give you like something to, this one doesn't, oh yeah, no, there shouldn't even be stuff there. Okay, letter B. In space, the set of points 3 inches from point P. What are you going to get?
Sphere.
A sphere, right? Everything 3 inches from point P in 2-dimensional would be a circle. Oh, so wobbly. It's terrible. Let me just get that out of there. Oh, let's do this. Let's do this. Oh, except it covered up my center. That's okay. Okay. But because it's 3-dimensional, to make it look like a sphere, then you do the great circle like this. This distance here should be 3 inches. Okay, so if it says in space, make it pop. If it says in a plane, make it flat. Okay. Questions on that?
So you said we didn't have to transfer it over?
Transfer what over?
Like put it in like the blank page?
Oh, no. Do it right on the point that I gave you.
This is the only homework we have.
That's all you have for tonight. No homework, guys. Oh, woohoo. All right.